Hello folks, so this is a video for you about Venn diagrams and how we use them to solve probability problems. If you are following along with me on your notes, I'm actually going to skip around on the notes a little bit and kind of talk to you about the basics. We're going to do and talk about the different parts and what those different parts of the Venn diagram mean, and then I'm going to show you an example with numbers and then another with probability. There is a practice problems video that goes with Venn diagrams if you want a little bit more practice, all right? So let's go ahead and jump into it here. So Venn diagrams, you, I'm sure, have seen these in lots of other classes that you've taken. A lot of people tell me that they see them the most in like their English classes when they have to compare and contrast something, or maybe in a science class or even a history class. Okay, and normally what you do with Venn diagrams in those types of classes is you make a list of things that either fit in one category or another category or both. And then you use that to like compare and contrast. Okay, it's essentially the same thing in math. It's just instead of like a list of items, you're going to have either numbers, so like totals in a particular category, or probabilities. So like how likely is it that you pull someone at random that fits in one of these categories, okay? So Venn diagrams show the relationships between two categories, right? And in math, it can have numbers or probabilities inside. So what you see here, okay, in the middle, right, is the intersection of both of those categories. So where they overlap, right? So this would be like an and probability, okay? In this little like kind of moon-shaped part over here, this is the probability that a person you select like only fits in one of the categories, only A. This one would be only B. And then the total circle, the total circle is like all of category A. This total circle is all of category B. Okay, and then anything outside of the actual Venn diagram, the circles, is things that don't fall in either category, so neither A nor B. Okay, all right, so I want to show you all, okay, and what really helps a lot of people understand Venn diagrams a little bit better is when they can see visually where things are shaded, okay? So if I wanted to know where the intersection of two events are, like I said, it's this area right here. So you would have to shade all of that in, right? It's where the two circles overlap, okay? Now, remember, a union in probability means that the person that you select at random could fit in one of the categories, it could fit in the other category, or it could fit in both categories. Okay, so an or probability is actually all of the space inside the Venn diagram. Okay, right? So if you're asked to find an or probability using a Venn diagram, you would have to add all of the numbers that are inside of the circles, the Venn diagram. Okay, all right, so I'm going to do a couple of these up here at the top, and then I'm going to give you a chance to try to shade some of these other ones. Okay, so for probability of A, that's just the entire circle A. Okay, so it can include part of the circle B as long as that's also included in circle A, right? So probability of event B is very similar. It's just the entire circle B. So if I wanted to find like the probability of this whole event using a Venn diagram, I would have to add up this part, which is only B, and then the intersection part in the middle, okay? All right, now, if you recall from a couple probability videos ago that this little guy right here, C, stands for complement, and it literally means or translates to the word not, okay? So when you're figuring out a not probability, okay, on a Venn diagram, what you do is you find wherever that normal area would be. So like probability of A would be this entire circle A. And if I want not that, I would shade everywhere else outside of that space. Okay. Very similar for probability of not B, right? So I would find, okay, where is B? So that's this whole big circle right here. And then I'm going to shade everywhere else that's not that circle B, right? So if I wanted to find the probability of not B, what I would do is I would add like this little moon type shape for only A, and then I would add the neither A nor B, okay? All right, so I'm actually going to pause my video, and I would love for you to do the same. And I want you to try these bottom 4 out just to see if you can kind of visualize where these things are in a Venn diagram. Okay, remember this little guy right here, the little dash also means not. Okay, so this is probability of not A or B. Okay, and then this one here is the probability of not A and B, right? So remember, with and, wherever you shade, it has to satisfy both of these things. But if it's an or probability, it has to satisfy one or the other, or both, all right? So go ahead and pause the video and check back with me in just a minute to see how you did. All right, folks, so go ahead and check your answers against mine. So for that first one in the bottom row there, that's not A and B, okay? So not A is everything outside of circle A. Right, so it's all of that. But wherever I choose has to also be in circle B, right? So I can't include like all of this stuff out here, right? Because that stuff out there is not also included in circle B. So what you see shaded in purple there is everything that fits in both of those categories, okay? Now the or probability is different, okay? Because I could fall in circle B, which is like this whole thing right here, which is what's shaded in pink, or I could fall in not A, which is everything that's not in circle A. So do you see how you have this little overlap space where the and part is, right? Even though this part, this overlap, is in circle A, it's in circle B. So it fits in this category and not necessarily this category, okay? All right, so for these last two, I don't think I mentioned this before I had you pause the video. That's my bad. But whenever you have a not on like the outside of a pair of parentheses, what you do is you figure out where you would shade without that. So like A or B is everything inside of the circles, okay? And then you would just shade the opposite of that. So literally everywhere else, right? So if A or B is everything inside the circles, I would shade everywhere else, okay? Which is all of the space outside of the circles, okay? Very similar idea here. So A and B is just this little intersection right here. So not that is literally everywhere else, right? And I know my drawings are not like super great because I'm just like scribbling. You can see them a little bit more clearly with the notation on the left-hand side, all right? So I'm actually gonna pause my video. Give me just a sec because I have to clear my screen off, but I'm going back up to the first page of your Venn diagram notes, and I'm gonna do an example for you with numbers, and then I'll do another example for you with probabilities. So I'll see you in just a second. Okay, so here's this first example. So we have at Annabelle High School, some students are taking Spanish and some don't. Some students take an art class and others don't. Okay, so we're saying S is the students who take Spanish. Okay, so that's what S stands for, right? It stands for Spanish. And then A stands for students who take art. Okay, and then we have this lovely Venn diagram of numbers. Okay, so it says here, look at the number 112 in the diagram, which is right here. So 112 is the students who are in Spanish but are not in art, right? That are not also in art, okay? All right, so let's talk about what do these individual numbers actually tell us, okay? So 84 is here in the middle. So that's the intersection of both. So that's the students who take Spanish and art. Okay. And then the number 56 here is, since it's outside of the Venn diagram, those are the students who take neither. So neither class. Okay, these students take neither of those classes. Okay. Now, part C is basically going to help us like figure out the rest of these here. Okay, because remember, whenever you're calculating a probability, you have to have the total, because otherwise you can't calculate the probability. Okay, so for the total number of students at the school, you have to add all of these numbers together. Okay, because that represents everybody, right? Because there's really only 4 types of students in this scenario. Students who take Spanish but not art, students who take art but not Spanish, students who take both, and students who take neither. Any person in that school could fit into one of those 4 categories. So if I want to find how many total students there are, I'm going to add all of those together. So 112 plus 84 plus 98 plus 56. And then when you add all of those up, you get a lovely, nice whole number, 350. Okay. All right. Next part, D, is what's the total number of students who take Spanish? So remember, if I want the number of students that take Spanish, that's everyone inside of the Spanish circle. So in order to figure that out, I have to add those 2 values there. So 112 plus 84, which is 196, okay? So then the next follow-up question is, okay, then what's the probability that I pick a student who takes Spanish? So remember, probability, I'm going to say probability of S, because that stands for Spanish, right, is the total number of successes, so the total number of people in that category, so 196 divided by the total, so the total number of students in the school, which is 350. And then if I plug that into my calculator, because honestly, I don't really want to do that in my head or try to reduce it. So if I plug that into my calculator, I get 0.56. All right. Okay, so I want you all actually to pause the video here for a second and try out those last 4 there. So F, G, H, and I, okay? Because I think with what you've seen in the video so far that you can figure those out. So try those and then check back with me to see how you did. All right, folks, so go ahead and check your answers against mine here. So part F and part G are very similar to D and E, just with the other category, right? So the number of students who take an art class is everybody inside the art circle, right? Everybody inside the art circle. So that's 84 and 98. I have to add those together. So I get 182 when I do that. And then the probability then is 182 divided by the total, which is 350. If you plug that into a calculator, you get this, 0.52. Okay. Now part H says how many students at this school take Spanish or art? Remember, or in a Venn diagram is all of the numbers inside of the Venn diagram. Okay, so I would add 112, 84, and 98. And when I do, I get 294. Okay, now my very last one says how many students do not take an art class? Well, that's just everybody outside of the art circle. So I have those numbers circled in orange. So these 112 students are not in an art class, and these 56 students here are also not in an art class. So you got to add those up and you get 168 when you do that. Okay, all right, so let's take a look now at an example that with probabilities, okay? So what I'm going to do is I'm going to help you kind of fill in the diagram, and then after that, I'm going to have you try these 4 probabilities, try to figure out what these 4 probabilities are right here, Okay, so here we're talking about students who play football and students who take a music class, right? So there's going to be some students that do both, some that do one or the other, and then some that do neither. Okay, so we have a couple of missing values that we need to fill in here. Okay, we need to fill in this missing and probability. We need to figure out what the total probability is for the students who are in music. And then we also need to figure out what this probability is right here. Okay, so first things first is whenever you see a little box like these outside of a Venn diagram, but like connected to the individual circles, that's just meant to tell you what the total probability is, or maybe what the total number is in that whole category. So like the total probability or percentage of students that play football is 21%. Okay, so what that means is that these two components, this one and this one, have to add up to 0.21. Okay, so I know that the probability of football is 0.21. Okay, and then the probability of just football without the music is 0.18, right? So the way I'm going to figure out the probability, that and probability of football and music, is I'm going to actually subtract the 0.21 and the 0.18. Right, because those are the two parts, right, of that 0.21 total. So that is 0.03. Okay, so this missing number that goes here is 0.03. I'm actually going to do a little bit of erasing here because I don't have quite enough space. So I'm going to write this a little differently here. So 0.03, okay? So then what that means is that the probability of music, this missing guy out here, is the sum of these two values, right? It's everything that fits inside that music circle. So 0.03 plus 0.77, which is 0.8, right? So that's what would go out here. So 0.8. Okay. Now, what I want you to notice is that these two individual probabilities, if you add them up, so like 0.8 plus 0.21, you actually get greater than 1, right? And that happens a lot when you're dealing with Venn diagrams. And the reason for that is because, remember, this 0.03 gets counted twice, both here in the 0.21 and here in the 0.08, or in the 0.8. Okay, so now the very last thing we have to figure out is this not probability. So people that fit in neither of those. Okay, so remember that the total probability inside of a Venn diagram has to be 1 or 100%, because that's all of the possible outcomes for this sample space, right? So I know that my total of all of these, so this, and this, which I don't know, has to add up to 1. Okay, so I know that 0.18 plus 0.03 plus 0.77 plus this value that I don't know has to equal 1. Okay, so I'm going to add all of these up. 0.18 plus 0.03 plus 0.77, and it gives me 0.98, okay, plus my value that I don't know has to equal 1, and then I'm just going to subtract 0.98, okay, and I get that value is 0.02, so that's what goes in my neither category there. All right. Okay. So now that you have that Venn diagram completely filled in, okay, I want you to pause the video, try out these 4 probabilities that are listed here. Okay. See if you can compute those, and then check back with me in just a sec to see how you did. All right, folks, go ahead and check back with me to see how you did here. Okay. So I have all the probability notation written out for you on the left side of the screen because I did not have space on my actual notes here. Okay, so for that first one, we wanted to find the probability that a student plays football but does not take a music class. So the way that you write that probability notation is it's football and not music. Okay, so that area inside the actual Venn diagram is all of the parts of the football circle that are not also included in the music circle. So it's just this, the 0.18. Okay. The next probability that we had to find, was what's the probability that a student takes a music class? Well, we figured that out here. Right? So it's just the total of everything inside of that music circle. So 0.8. Okay. The next one says, what's the probability that a student plays football and takes a music class? So remember, that's the intersection part. So it's where those two circles overlap. So that's 0.03. Okay. And the way that that's written in probability notation, you can see it on the left-hand side. So it's F and M. Okay, and then the last one is what's the probability that a student plays football or takes a music class? So that's F and then union, because remember union means or, M, right? And remember with an or probability in a Venn diagram, the easiest way to figure that out is to just add all of the values that are inside the Venn diagram. So 0.18, 0.03, and 0.77 if you add all those up, which we actually did over here already, okay? And another way you could figure that out if you wanted to is you could have done 1 minus the not probability. So that would be like one other way you could solve it, right? You could have done 1 minus 0.02 because that would give you everything else, right? Everything else that's left inside the Venn diagram, which is 0.98. Right? So those would be your two ways that you could figure that or probability out. All right, folks, so that is it for this video. I do have one more Venn diagram video for you. So if you're not feeling super confident with these and you would like a little bit more practice, check out the Venn diagrams practice video. Whatever video you watch next, I will see you there in the next one. All right. Bye, everybody.